All right, everyone. This is the 10th and the penultimate MediaComp video. Today we're going to talk a little bit about how to make collages, which is sort of bringing together some of the copying stuff we've been doing. And then we are also going to talk about how to do color splash and how to do edge detection. Just a little bit, though. All right, so if you would like to create a collage, so say we have two pictures, flower 1 and flower 2. Both pixels are 100 pixels wide. The target picture is 640 by 480. You can copy them one at a time. You want to copy them probably a little bit above the bottom, just so that you can see things a little bit better. But you just use the regular copying methods that we've already seen in previous videos. So to actually do that, you would create the target picture. So in this case, we're using a 640 by 480 file. And there is one in the media sources folder, so you can take a look at that. You invoke the method on the target picture, and then inside the method you create the flower pictures, which you can do by using set media path and get media path to grab the pictures. You set the bottom target and then copy those pictures, and then repeat using other pictures. You can have the pictures overlap. You can have them. You can create different effects, and then you can overlap them. Things like that. So the idea, and this is just something for you to think about, create a collage. Take at least 4 copies of an image, make the initial image, and then have 3 changes to it: scale, rotate, crop, change colors, negate, grayscale, whatever you want to do, and then sort of mirror the whole thing horizontally. Remember that you can save your pictures using whatever the picture object name is, .write, and then give it the fully specified path name. That'll work just fine. Okay, so we'll be talking more about this in lab as we go into doing the Photoshop Junior problem set. So, okay, so you may have all seen commercials of this type where you have a black and white, or actually what we've been calling a grayscale picture, with just a splash of color in it. So this is called color splash effect, and it converts pictures to black and white while keeping the chosen details in color. Instead of doing it the other way, taking a black and white picture and trying to add color to it, we take a color picture and we subtract color out of it, except for the places where we want it to be. For example, here's some examples of this. This is one of the many Coca-Cola commercials that have done this. You notice that just the label and just the little ring around the top are in color. This one's a clothing manufacturer where they just have yellow and everything else is black and white. You can do all sorts of things. I'll show you an interesting example. So now the question then is, how do you do this kind of stuff? So ideas, you go ahead and think for a minute. I'll wait. Okay, now that we're back, here's my ideas. First, what you want to do is you want to isolate the areas you want to keep with color and then turn the rest into grayscale. That's one idea. Actually, what I want to identify is not the areas that you want to keep in color, but I want to identify the colors that you want to keep. And so that's the answer. The bottom one is, what colors do you want to preserve in this? So how do you figure out which color to keep? Because you can't do just exactly one color, right? I want to keep 205, 76, 127. That's not going to work very well, because there'll be precious few pixels out of 16 million possible colors that will have exactly that combination. So typically what you want to do in color splash is you want to get all of the pixels that have colors that are close to the color that you want to keep. And the question then is, what do we mean by close? And that's what this is all about. It's all about distance. And so the question, first of all, is how do you compute distance? Well, if we're talking a two-dimensional object, we would do Cartesian distance. And if I have two different points in Cartesian distance, then of course the distance is just the square root of x1 minus x2 squared plus y1 minus y2 squared. And how does that work in 3D? Well, it turns out, of course, in 3D that this just extends. So the Cartesian distance between 2 points in 3 space is just the square root of x1 minus x2 squared plus y1 minus y2 squared plus z1 minus z2 squared, because you, of course, have that third dimension. And so this is what it looks like. We could do it in 2 steps. We would have a variable called squares, and we take x1 minus x2, and this is just me telling you how to square things, but this doesn't work in Java, by the way. Plus y1 minus y2 squared plus z1 minus z2 squared. And then you take the square root of that sum to get the distance. The idea is that colors are just like points in 3 space. If you think of 3 space as being starting at 0, 0, 0, which is the origin of 3 space, then you can go 255 units in the x direction, 255 units in the y direction, and 255 units in the z direction. And so you, in a sense, have this cube, which is 256 units on a side. And all of the possible colors that you have are inside that cube. Now, we don't want to do that because we don't care about all the colors. We just care about one of the colors. Okay? So that the color you want to keep is some stationary point in 3 space inside that cube. And you want to keep the shades of that color that are within a certain distance, which will have some kind of a boundary value, of your stationary point. Okay? That's what we're trying to look for. That will get you colors that are close to the target color, but not exactly the target color, so you'll get a lot more pixels in your color splash area. Okay, so what you can do is think of your stationary point as the center of a sphere in 3 space, and you want to preserve any color value that is within the radius of the sphere. And the radius of the sphere is the furthest distance away. So the surface of the sphere is the farthest, the colors that are the farthest away from your stationary point and your designated color. And so any colors inside that sphere we want to preserve, and any colors outside that sphere we want to turn into grayscale. And that's the idea behind Color Splash. Here's a little visual thing. So here's my sphere. There's a radius, and there's the center of my sphere. And so anything inside this sphere is a color that I want to keep in my picture, and anything that's outside the sphere is a color that I want to turn into grayscale. All right? So let's take a look. I'm actually not going to show you the code because I'm going to want you to write it yourself in the Photoshop Junior problem set. But we can go over here and I can show you an example of how we do Color Splash. So let me uncomment some of this stuff out and comment this other stuff here. Oh, and then I need to add, no, that's fine. And then I'm going to comment that out too. So what I'm going to do here in here's my Color Splash class. and I have an empty constructor. And what I do is I create an instance of myself so that I can make all of my methods not static. They're just instance methods. I'm going to create a scanner because I'm tired of having to restart the recompile whenever I want to do a new picture. And so I'm going to set the media path to where my media sources directory is. Then I'm going to prompt the user for the name of the picture that I want them to type in. And they will type in the name including the .jpeg at the end. I'll grab that using the scanner. That returns me a string. And then I can use that string inside as the argument to the getMediaPath method, and I can then create a new picture out of it. I'll show the picture. I'll do the color splash. I need to add a snooze. We'll wait a little bit, and then we'll repaint. And so you can see what the picture will look like. And I think we're ready to go. So let's try this. I have a picture that should look pretty good in its color splash. So and I need to enter the picture. The picture is called Red Door. And oh, it does it too fast. Okay. There is an example of color splash. This is a red door picture, and everything else has been turned into grayscale. So you can see how well that works. This one works really well, actually. In fact, let's go back though, and let's. I'm gonna grab this and create a target picture. Actually, where am I going to put my target picture? Oh, I know what I'll do. No, I won't. No, I'll do it later. Never mind. Okay, so that's so much for color splash. The next thing that I want to do is edge detection. Okay. Now remember when we were doing just the black and white example, it worked out pretty well, but we lost a lot of the details. There was a little too much contrast. So we might be able to keep more of the contrast if we could figure out where parts of the picture change colors. In a sense, where edges will happen in the picture. And so we're going to use a very simple technique to do this. We're going to look at a current pixel, and then we'll look at the pixel that's immediately below it in the rectangle of the picture. And we will compare the differences in their colors. And if the difference between the two pictures, if the pictures are sufficiently close together in color, I'm going to make them white. But if the difference is large enough, I'm going to make it black. And so sometimes you can want to do that high contrast thingy where you just black and white, and we discovered, yes, we might be able to do more of a contrast if we could figure out that. So let's see an example of where this works. And let's see, now I'm going to comment out that, and that, and that, and uncomment this and this. And then I'm going to uncomment this too, because I want to show you an example of how we write pictures out. So I'm going to do the same thing I did before. I'm going to set the media path. I've got my scanner. I'm going to read in the name of the picture that I want. And I'm going to create that picture. I'll display it. Then I'm going to call my edge detection method. And this is going to be the difference in the color intensities that I want. And we can fiddle with this a little bit. And this method, as opposed to the color splash method, this method does return a picture. So we'll return that picture, and then we'll show it, and then we'll write it out so I can show you what it looks like. And once again, I'm not going to show you the code because I'm going to want you to do this. So I need to compile this. That looks good. And we'll do this now. And I need my picture, and I can't. Oh, right. Butterfly1.jpg is one good picture. And here's the original, and here's the picture with edge detection. Notice it's better than just the black and white picture was. In fact, I will show you the difference because we did the one black and white picture using a picture of swans. And I'll show you that one. So let's quit that. Oh, and I wanted to show you I successfully saved the file. So I have this file on my desktop now. But every time I do it, I'll overwrite the file, and that's okay. So now I don't have to recompile. That's what the scanner is for. I can just do this, and the name of the picture that I want is swans.jpg. And there's the original swans picture. This is the one that we converted into black and white. And remember, we could hardly see the swans, and so now we do a better job of picking out the swans. This looks a little better. This was just dead white before. This part is, of course, white because it started out white, but you can see a little bit of trailing clouds here. And so this one looks somewhat better. We can try this again, and this time I do have to recompile because I'm going to try this and I'm going to make the difference like 20. And we'll see what happens. Oh, and I'm going to comment that out so I don't overwrite the picture. And we'll try the swans again with a different threshold amount. And thunk thunk. Now there's the different threshold amount. There's the original picture. See, that's a little bit too much. Here was the threshold amount when the threshold amount was 10. So this is threshold amount of 10. We get a little bit more black in here. Threshold amount of 20, and here's the original picture. We might actually be able to go down to a threshold amount of like 5 or 8 or something like that and get a better picture. So that's pretty much all I'm going to say about edge detection. And it's also pretty much all I'm going to say about color splash. And so we're done. You guys have a good evening, and we'll talk to you later. Bye.